A short video on integration by parts. So we have the integral of sine of x cosine of x dx. If you did this by substitution, you end up getting the answer as sine squared of x divided by 2 plus c. So that is integration by substitution. Now let's do integration by parts and see if we get the same answer. So now we have sine of x and cosine of x. So these are both trig functions. It doesn't matter what you make u and what you make dv by dx. So in our case, let's just make u is equal to the sine of x, and then dv by dx is equal to the cosine of x. Okay, and then that means we need to find du by dx and v before we start doing anything. So du by dx is equal to the cosine of x, and v is equal to the sine of x. Right there. Okay, so now we have the integral of sine of x cosine of x dx. We have all the things that we need. We just need to apply the formula. So the formula says the integral of u dv dx is equal to uv minus the integral of v du by dx. So we have everything we need. So I'm going to do something. I'm going to call this integral I. I'm going to call I is equal to the integral of the sine of x times the cosine of x dx. And you will see why soon, because, yeah, you'll see. So now what do we have? We have that is equal to uv. So we have sine of x times sine of x. So that's sine squared of x minus the integral of v times du dx. So we have v, which is sine of x, and then du dx is equal to cos of x. We have sine squared of x minus the integral of sine of x times the cosine of x with respect to x. So what's happened right here? Well, we've applied the formula, but then we have ended up getting something which is still very difficult to integrate. We still need to use integration by parts for this, because this is also a product of two functions, right? But this right here is actually our original integral, so, which is equal to I, right? So we have I is equal to the sine squared of x minus I, right? Because that is the integral that we need. So now all of that's gone away, so now we can rearrange it. So we can have 2 times the integral, so 2I is equal to sine squared of x. And then what do we have? If you divide both sides by 2, we have I is equal to sine squared of x divided by 2. But what is I? I is the integral that we needed. I is equal to the integral of sine of x cos of x dx. So that means the integral of the sine of x times the cosine of x with respect to x is equal to the sine squared of x divided by 2 plus c, of course, always. And that is exactly what we would get if we integrated by substituting u is equal to sine of x and then we found du dx. So you can see the integration by parts can work. As soon as I make it more difficult, as soon as I say the integral of x e to the x dx, well, now substitution's out of the window. You don't know how to substitute, right? But using integration by parts, you can easily get that done. So you can see why integration by parts is such a useful tool. So I hope that makes sense. Just a quick video on an application of integration by parts. So yeah, like, share, comment, subscribe. Let me know what else you want to see in future videos.